So 12th standard physics volume 2 unit 6 ray optics book back answers we are continually seeing. So in this way we are going to dealing about numerical problems. 10 problems they are given to us, right? So page number 50, first problem. An object of 4 cm height is placed at 6 cm in front of a concave mirror of radius of curvature 24 cm. Find the position, height, magnification and nature of the image. So answer they are given. V is equal to 12 cm and h dash the position on the v position is v 12 cm, height is 8 cm and the magnification is 2. Image is erect virtual twice the height of object formed on right side of the mirror. Okay, so how the answer is come to the place? Okay, now we are going to take. So the answer is the first given data, the height of an object h is equal to 4 cm. The data are given. Okay, distance of an object from concave mirror u is equal to 6 cm. After sign convention, u is equal to minus sign convention, minus 6 cm. Radius of curvature of concave mirror r is equal to 24 cm. Total focal length of concave mirror f is equal to radius of curvature of concave mirror divided by 2. That's the focal length. F is equal to 24 divided by 2, 12 cm. That is for total focal length of concave mirror. After sign convention, f is equal to minus 12 cm. So image distance v they are asking. So we know the length formula 1 by f is equal to 1 by u plus 1 by v. So f is we know minus 12. 1 by minus 12 equal to 1 by minus 6 plus 1 by v. So we need to find 1 by v. So 1 by 6 already here. So 1 by 6 to the left side. So 1 by v is equal to minus 1 by 12 already here. So minus 1 by 6 come to that equation next side means plus. So plus 1 by 6. So taking LCM 12. These are the 12 factors. So 1 6 are 6, 2 6 are 12. So 12 is the LCM. So here we multiply the 12, 12 cancel, minus 1 comes here. 12 multiply the 12. So 1 6 are 6, 2 6. So 12. So plus 2. So minus 1 plus 2 equal to 1 by 2. So v is equal to 12 cm. Next magnification they are asking. M is equal to the formula is image distance divided by object distance. M is equal to minus v divided by, we know that image distance is v, object distance is u. So minus v by u. So minus 12 by minus 6 the given data. So equal to minus minus cancel, 1 6 are 6, 2 6 are 12. M is equal to 12. Height of the image h dash they are asking. Magnification is equal to height of the image divided by height of the object. So m is equal to h dash divided by h. 2 is m is equal to h dash divided by 4. H dash equal to 4 into 12, 8. H dash equal to 8 cm. So as the object is placed between p and f, we get virtual and erect and erect image twice the height of the object formed the right side of the mirror. Okay, that's the answer. So second question, an object is placed in front of a concave mirror of focal length 20 cm. The image is formed 3 times of the size of the object. To calculate the possible distance of the object from the mirror. So answer is plus m u is equal to minus 40 divided by 3 and with minus m u is equal to minus 80 divided by 3. How it is come? So the solution is given data. The focal length of the concave mirror f is equal to 20 cm. Magnification is m is equal to 3. Okay, 3 times. Okay, 3. So first case, when image is virtual, m is equal to 3. Magnification m is equal to minus v by u. That means 3. So minus v by u is equal to 3. Minus v is equal to 3. U v is equal to minus 3u. According to the mirror equation, 1 by f is equal to 1 by u plus 1 by v. F is equal to minus 1 by 20. So 1 divided by minus 20 equal to 1 by u minus 1 by 3u. So minus 1 by 20 is equal to, so taking LCM 3u. So multiply with the 3u means 3 3 cancel. So 3 only, u cancel, u 3 only come. So while you multiply with the 3u 3 cancel, minus 1. So 3 minus 1 2. So 2 by 3u. So 3u divided by 2. So cross multiplication. Okay, 3u divided. So in the changing the numerator to 1 divided by, okay, divided by 1. That's all. 1 divided by. So that means numerator come to denominator, denominator come to numerator. That's all. So that means 3u come to numerator and divided by 2 is the denominator equal to minus 20 divided by 1. That means minus 20. So 3 equal to minus 40. U is equal to minus 43. 40 by 3 centimeter. That's all. So in the second case, when the image is real, m is equal to minus 3, magnification is m is equal to minus v by u, minus v by u is equal to minus 3, v is equal to 3, minus minus cancel. So according to the mirror formula, 1 by f is equal to 1 by f is equal to 1 by u plus 1 by v, minus 1 by 20 equal to 1 by u plus 1 by u, 3u. So minus 1 by 20. So taking LCM 3u. So multiply with the 3 means u cancel 3. 3u means 3u cancel plus 1. So 3 plus 1 4. So just arrange that equation. 3 divided by 4 is equal to minus 20. So minus 3 is equal to 4 2 are 8 minus 80. So is equal to minus 80 by 3. So two possible distance of the object from the mirror is minus 40 by 3 and minus 80 by 3 centimeter. That's all. Third question is a beam of light of consisting of red, green and blue is incident on the right angle prism as shown in the figure. The refractive index of the material of the prism for the above red, green, blue color is 1.39, 1.44, 1.47 respectively. What are the colors of a total internal reflection? Okay, so the answer is green and blue suffer total internal reflection. How? So the solution is the light incident of the surface AC. Okay, so it's just write the name at the right angle incidence 45 degree. That means angle of incidence I is equal to 45 degree. For total internal reflection I is greater than of IC. So 45 degree is greater than of critical angle IC. So sin 45 degree is greater than of sin IC. That means 1 by root 2. So in the page number 19 they give the explanation, right? So critical angle is angle of for total internal two condition total internal relation takes place. I is greater than of IC. Okay, page number 19. So in this manner sin 45 degree greater than sin IC. Sin 45 degree is 1 by root 2. So greater than of 1 by n. That is refractive index, or n is greater than root 2. So 1.44 414 is greater than of n. So the given is refractive index of the prism. For red is refractive index 1.39. So for green 1.44. For blue 1.47. They given data in the view. Now refractive index of green is 1.44. That means 1.47. They given to. So green is 1.44. Okay, first one is red, the second one is green. 1.44 is less than of 1.414. Okay, the symbol is I just write in the wrong. I misunderstand. So this is right. So 1.4 is greater than of 1.414. 1.47 is greater than of 1.414. Right. So this value is higher. That's the meaning. Green and blue. So red is less than 1.39. So from this green and blue light will suffer total internal reflection. So the red color will be transmitter. So this is the answer. Okay. So fourth question is an object is placed at a certain distance from convex lens of focal length is 20 cm. From find the object distance if the image is obtained is magnified 4 times. The answer is used 15 cm. Right. So the given data is focal length of the convex lens is 20 cm. That means f. To find the magnification, m is equal to 4. They are given. Right. Magnified 4 times. Okay. U by v. The lens that means v is equal to 4u. So lens formula 1 by v minus 1 by u is equal to 1 by f. So 1 by v is equal to 4u minus 1 by u equal to 1 by 20. So they are asking u. Okay. That means object distance. V means image, U means object, that's all. So 1 minus 4 divided by 4u by 1 by 20. So very simple, minus 3 by 4u equal to minus 1 by 20. So 20 is equal to 4 by minus 3, 4u is equal to minus 60, u is equal to minus 60 divided by 4. So just to divide 1 4 of 4, 2 5 5 are 20. So u is equal to 15 centimeter, that's all. So fifth question is obtain the lens maker formula for a lens of refractive index n2 which is separating two media of refractive indices n1 and n3 of the left and right respectively. So the answer is given. So we just check it out. The given data is the lens maker's formula. Refractive index is one thing is n2, another one is n1 and n3. Okay, this is object distance, this is image distance. So this was that. So using the formula for refraction n2 divided by v minus n1 divided by u is equal to n2 minus n1 divided by r. So for the first case we have from n1 to n2, n1 to n2 like this. So n2 divided by v minus n1 divided by u equal to n2 minus n1 divided by r1, equation number 1. For the second case we have n2 to n1, n2 to n1. So n3 divided by v minus n2 divided by v dash equal to n3 minus n2 divided by r2. So both already we have present v, so that's we noted as v dash. Okay, that's all, nothing. So n3 minus n2 divided by r2. So adding equation number 1 and 2, n3 divided by v minus n1 divided by v is equal to n2 minus n1 divided by r1 plus n3 minus n2 divided by r2. So the first equation is we checked n3 divided by v minus n1 divided by u is equal to n2 minus n1 divided by r1, n3 minus n2 divided by r2. So correct. So to find the focal length, so this is u, okay, u. So to find the focal length, 1 by v minus 1 by u. So just divide with n3. So eliminate this term. That's all. So 1 by f is equal to 1 by n3 into n2 minus n2 by r1 plus n3 minus n2 by r2. That's all. So sixth question: a thin converging lens of refractive index 1.5 has a power of 5.0 d. When thin lens is immersed in a liquid of refractive index n, it acts as a diverging lens of focal length 100 cm. What must be the value of n? The solution given data: n refractive index of glass is 1.5. Okay, they are given. G means glass. So power Pg is equal to 5.0 d. So Na means air equal to 1. We know that. So Fe is equal to minus 100 centimeter. That means focal length. Okay, focal length immersed in the liquid minus 20 centimeter. That means minus 1 meter. Okay, just divided by 100 to convert the centimeter to meter. So to find n, so the power of a lens in liquid, PL, power of lens in liquid, 1 divided by GL, FL. Okay, 1 by FL. So that is equal to 1 divided by minus 1. So this one. Okay, Fe. So 1 divided by minus 1, that means minus 1 d. Power of a lens placed in the air. So power of lens in the air means 1 by F. That means Ng divided by Na minus 1 into 1 divided by R1 minus 1 divided by R2. Okay, that's all. So Pg is equal to 1.5 divided by 1 minus 1 into 1 by R1 minus 1 by R2, equation number 1. Power of lens in the liquid. So PL. Okay, this one is gas, this one is liquid. So Ng divided by N minus 1, 1 by R1 minus 1 by R2. So the just Ng we have the value 1.5 divided by N minus 1 into 1 by R1 minus 1 by R2, equation number 2. So 1 divided by 2, we have that air, glass and liquid. So just divide 1 by 2. So both equation cancel. So this term only exists. So very simple mathematics solution. 5 divided by minus 1 is equal to 0. So we have the value, right? So Pg is equal to 5 and PL is equal to minus 1. We have the value. So just substituted. So 0.5 divided by 1.5 N minus 1 divided by minus 1. So minus 5 is equal to 0.5 divided by 1.5 minus 1. 1.5. So just multiply. Rearrange the term. So 1.5 divided by N minus 1 is equal to minus 0.1 divided by 1. That means 1 minus 1 by 10. So this minus 1, if you go to the right side, plus 1. So 1.5 divided by n is equal to minus 1 LCM, minus 1 plus 10 divided by 10. So 9 by 10, 1.5 is equal to 9 by 10. So just arrange the term, 10 into 1.5 is equal to 9 n, 15 is equal to 9 n is equal to 15 divided by n. So that means 5 by 3. So seventh question is, if the distance between if the distance d between object and screen is greater than 4 times the focal length of F or focal length, then there are two positions for which lens forms an enlarged image and a dimensional image respectively. This method is called the conjugative Fourier method. If d is distance between the two positions of lens, obtain the equation for focal length of the convex lens. Okay, so very simple. So they are asking that if the distance d between object and the screen. So object capital D is object and the screen. Okay, object and the screen. This one. Screen is 4 times greater than 4 times of focal length, right? D is equal to 4 times of focal length. So they are asking to find the focal length of convex lens. D is equal to u by u. D is equal to, that means D is equal to u, image distance, object distance and image distance. So u plus v. That's it. So small d is equal to v minus u. Small d is v. This is completely v. Okay, minus u. That's it. So total length minus object length. That's all. V minus u. So 1 plus 1 d plus d is equal to. So just add plus u minus u cancel. D plus d equal to v. So v is equal to d plus d is divided by 2. If 1 just minus, so v will be cancelled. So that means u is equal to d minus d divided by 2. So from the lens equation, 1 by f is equal to 1 by minus 1 by minus u. So 1 by f is equal to 1 by v plus 1 by u. That means u taking LCM, u plus v divided by uv. F is equal to uv divided by u plus v, equation number 5. Substitute that equation 3 in 4 and in 5. So u and v value will have to substitute. That's all. So u and v value will have to substitute. So commonly 1 by 2, 1 by 2, 1 by 4. So d plus d. And 1 by 2 is common, just take it out. So a plus b, a minus b, a square minus b square. So dd cancel 2d. So 2 cancel divided by d. So 1 by 4, 4 will become denominator. So f is equal to d square minus d square divided by 4d. So next 8th question. Prove that a convex lens can only form a virtual erect dimensional image. So the answer is convex lens will not form a virtual erect dimensional image. So concave only consider. So concave lens is always will give a virtual erect dimensional image, whatever may be the position of the object. When the object is at infinity, so at infinity, so this is a focal length. This is the point of a convex lens. Okay, so that in two possible image will be happens. So from this we consider position of the object, position of the image, size of the image, nature of the image. At infinity, the position of the image is f1. See, position of the image is f1. Size of the image is highly dimensioned. Nature of the image is virtual and the erect. So position of the object is optical center and infinity. That is F1 and O. F1 and O. So this one. Okay, this is what at infinity at position of the image is F1, size of the image is highly diminished, nature of the image is virtual and erected. And second option is between the optical center and infinity, between F and O of the image will be happens. If the object is placed between the optical center and infinity, the image will be F1 and O. So size of the image is diminished, nature of the image is virtual and erected. So a concave lens always form from a virtual image of an object because it diverges all parallel so that they appear to come from focus on the other side of the lens. So ninth question, a point object is placed at 20 cm from a thin plano convex lens of focal length 15 cm whose plane surface is silvered. Locate the position of the nature of the image final image. So the solution is consider the arrangement to be the combination of convex lens and plane mirror. The light ray from the object strikes the plano convex lens and the distance of the first image will be V1. So this is what 20 cm. Okay, so where that object is placed in the plano convex lens, which is silver place. So focal length is 15 cm. So that means u is equal to minus 20 cm according to the formula 1 by v1 minus 1 by u is equal to 1 by f 1 by v1 plus 1 by 20 is equal to minus plus 1 by 15. So 1 by v1 is equal to 1 by plus 1 by 20 into the right side means minus 1 by 20 plus 1 by 15. So taking LCM 20 15 means 60. 4 5 are 12, 12 5 are 60. 60. Taking multiply that 60 means 0 0 cancel 3 minus 3 plus 4. So 1 by v1 is equal to 1 by 60. v1 is equal to 60 cm. This image serves as a virtual object for the mirror and real image is formed at a distance of 60 cm to the left of mirror, and in turn this serves as a virtual object for the plano convex lens. So u is equal to plus 60 cm, focal length is equal to 15 cm. So this lens equation is 1 by v minus 1 by u is equal to 1 by f. So 1 by v is equal to 1 by 60 plus 1 by u. So 1 by v is equal to 1 by 12, that means v is equal to 12. As per the sign convention, the distance to the left side of the pole is negative, v is equal to minus 1 by 2. So the final image is formed to the left of the lens. So next 10th question is find the ratio between intensities of lights of wavelength 500 nanometer and 300 nanometer which undergo Rayleigh scattering. According to the Rayleigh scattering, intensity is proportional to 4 power times of inverse powers of wavelength. Okay, so I is proportional to 1 by lambda power 4. Intensity of light, the first wavelength is 500 nanometer, second wavelength 300 nanometer. So I1 is proportional to 1 by lambda 4, I2 is proportional to 1 by lambda 4, power 4. So I1 divided by 2, lambda 2 divided by 4 divided by lambda 1 power 4. So power is common, so take it out the common side. So 310 minus 9 divided by whole power 4. So power is common, so 310 minus 9. So 10 minus 9 divided by minus cancel 3. So 300 divided by 500 whole power 4. So all will be cancelled. So 2 0 will be cancelled. So 2 0 will be cancelled. 3 power 4 divided by 5 power 4. So 4 times 3 and 5 4 times 5. So 9 9 9. So 3 3 7 3 7. 5 5 25 25. So 81 divided by 625. I1 ratio of I2 is equal to 81 is of 625. The ratio of the intensity is 81 into 625. So that's all the answer of all the numerical problems. I hope this will be fine to understand. So thank you.